This is what we did last time. So any questions in this one?
No, sir.
Okay, try this question. Got the answer?
No, sir.
No, a particle moving in a circular path, uniform circular motion. That is mod v is constant, right?
Yeah.
And the direction is constantly changing. And the acceleration is towards the center. Centripetal acceleration. So, this will satisfy this one. If it moves in a circular path, then it will satisfy all the given conditions. Okay, the force is constant. The direction of the force is the same direction of acceleration, and the velocity are perpendicular. And it's a planar motion. And since the speed is constant, the kinetic energy is also constant. Okay, velocity is not constant because the direction is changing. Acceleration of the direction is changing because here the acceleration is this way, at this point it is this way, always towards the center, but these two are not parallel vectors. The acceleration is also changing. And the acceleration vector, okay, but the magnitude of acceleration is constant. Because force is constant, magnitude of acceleration is constant, but acceleration as a vector is not constant. Okay. So C and D are the correct options. Clear?
Yeah.
Okay, try this one. So first, what do you have to do?
Find the force.
Force on what?
Block.
Yeah, so what is that force? Another thing is you can find the acceleration. Okay, initial velocity is 0, right? And you can find the velocity at 1 second. Okay, so the gain in kinetic energy is the work done on the mass, right? Velocity at 1 second you can find it once you find the acceleration. So you have to find the acceleration.
Sir, 8 joule, 8 joule.
It is square, no? So how did you find out kinetic energy or some other method?
Sir, I found out acceleration first.
Found out the
And acceleration.
Okay.
And then kinetic energy and
And
acceleration I got as 10 by 3 meter per second square.
so this is the expression, right?
Yeah.
Okay. Accelerating disturbance. This is how much? See, this is 0.6 square, right? 0.36, 0.6 square, 0.6 and 0.6. So it is 0.6 into 3.6 divided by 1.08 whole square.
Sir, I'm getting, yeah, I got that only.
So this is 3 times this. 3. No, it's exactly 10 by 3.
Yeah, exact.
Because G is 10 only.
Hmm.
Okay, fine. Move the next one. This
Yes,
one.
then. So we have to use work energy theorem, right?
Yes. So initial energy equal to final energy equal to initial energy plus work done. Friction means work done by the mass. So it will be negative work done. This is very simple.
Hmm.
There is an initial velocity also because of the impulse. So initial energy is half mv square. That should be equal to final energy, which is the half kx square plus the work done against friction.
So what is N?
N is a number that you have to find out. It could be integer question. So n could be an integer. Integer.
We have to find velocity basically.
Yeah.
So I got V is equal to 1.2 by 3.
So n is 12 then. 1.2 by
3.
that is 0.4, right?
Yeah.
So n is then 4.
N is equal to 4. So we will take square root, I guess.
Okay, do it properly then. No, the answer is what you said is correct. V is 0.4 because V square is 1.6. So n is 4. Yeah. So got it?
Yeah, I got that.
Okay, try this one. Try to understand the question.
Sir, it is very bad question.
Understood the question?
Sir, I'll read again.
Initially, the ball is here at the topmost point. It will keep sliding like this, right?
Yeah.
At one point, see, this size of the ball is slightly less than the width of this between the two. Okay, so it will touch only the bottom sphere here. Okay, it will not touch the top one. But after a certain point, it will lose contact. At that position, the normal reaction will become zero. So you lose contact and it hit this one. Okay, once it hits this one, it will lose contact with this inner sphere. So it will touch the outer sphere and move like this. Okay, so until this point, the normal reaction on the sphere B will be zero. And after this point, the inner sphere, the normal reaction will be zero. Okay, so we have to split this problem into two parts. First, we'll be on the inner sphere, find the theta at which the normal reaction is becoming zero, and get the expression for normal reaction. Problem as such is simple. You just have to split into two parts. Okay, so you draw the free body diagram. The first part is the sphere A. So at a particular angle theta, the vertical, so you have to draw the forces. It's very simple now, you can do it. Try it. Okay, so this angle is theta, so this angle is also theta. N plus NB square by R equal to mg cos theta. Okay, and how will you find velocity? By energy equation. Loss in potential energy will give that velocity, right?
Yeah.
Loss in height, that is R minus R cos theta. So you can write mv square as 2mg this thing. So m equal to mv square by R is there. R is here, so you can take R here. So you can write mv square by R as n plus mv square by R, right? So mv square by R is 2 times mg to 1 minus cos theta. Is this right? mv square by R is this one and then the R out here. So if you know that it become 2mg into 1 minus cos theta. So 2mg into 1 minus cos theta. Okay. So now 2mg cos theta will become 3mg cos theta minus 2mg equal to the normal reaction. Okay. And This is cos 0, right? And cos will go down like this. This is cos theta. So cos theta is going to decrease. The normal reaction will decrease. At one stage, it will become 0. So at initial position, when theta equal to 0, so normal reaction is mg. Normal reaction on surface A with respect to as a plot of cos theta. So this is one point. The value is mg. Okay, and it will become with respect to cos theta, a straight line. Okay, when cos theta becomes 2 by 3, when cos theta becomes 2 by 3, the normal reaction becomes 0. This is actually NA, normal reaction surface. So this is the plot. Yeah, as a function of cos theta, you would have plot. Is it clear?
Yes, sir.
It's a straight line. So the question is not difficult, just that you have to split it into two parts. After that, it's trivial. So these are the two equations. So combining this as one equation, and you're getting this normal reaction as function of cos theta. So similarly for the B part, the sphere is inside. Okay. U angle theta. So the normal reaction will be inwards. Mg is downwards, and Nb square by R is outwards. So again, you have to write the equation. This is actually Nb. So Nb plus Mg cos theta will be Nb square by R. Okay. But the velocity equation is same because it will already satisfy this one. It does not matter which sphere it touches. So energy conservation is the loss in height will give the gain in the velocity. Okay. Again, Mv square by R you can write. So Nb plus Mg Nb square by R, so that is 2mg into 1 minus cos theta, right? So 2mg minus will become 3mg, right? So this plot is up to this value of theta, that is 2/3, right? Okay. This is good. Up to 2/3 will be 0 because there is no contact. After that, with cos theta, it is okay. The negative sign. Yeah, at this bottommost point, it's 180, right? So it is -1, cos theta is -1. So it is 5mg. And at cos theta equal to 90, it is 2mg. Cos theta equal to 90 is okay. So cos theta is becoming -1. See, oh, yeah, the value of cos theta is decreasing. No, see here originally cos theta is +1. Okay, but then the value of plot of cos theta is going this way. 1, 2. I think I made a mistake here. Okay, originally the value of cos theta is 1, right?
Yeah.
So 1 is somewhere here. That time the value is mg, after that becoming 0. So this is not the plot. This is the plot. Right? So it's going this way as theta is in this direction, theta is increasing, cos theta is decreasing. So the plot is going this way. And in this one, the plot will go from 2/3 to -1. So this is 5 mg. Okay, before that it is 0. From here it will should start increasing. Getting it? That's why the slope is negative here. Negative slope, right? With respect to cos theta. Here it is positive slope with respect to cos theta. Here the slope is positive, right? So that's why this line is there. Here the slope is negative. That's why it's like this. This picture is correct. Okay, for NB. Here it should be, this should have been reversed. Is that right? No, correct. The direction is this way. Actually, it's going this way. So what we did is correct. 2/3. This is NA and this is NB. So is it clear?
Yes, sir.
Okay. The question is not difficult, just that you have to understand that after sometimes the thing will touch sphere B. Okay, initially sphere A will contribute, after that sphere B will contribute. Okay, this one?
Yes, sir. Understood, sir.
Okay. So first thing is whether the statement 1 is correct and statement 2 is correct or true or false. After that, you have to check whether the statements are related.
Okay. So coefficient of friction will not increase, right?
No, it's a surface dependent thing. Depends on the surface, it will not change.
It will change.
No, mu is constant. Coefficient of
Yeah.
friction is mu, right? It's a surface property. It's
So
not
answer
depend.
is C.
Statement 1 is false, definitely. See, the decrease in kinetic energy is half m initial velocity square minus half m. What is the final velocity?
So both are wrong.
No, just answer what I'm asking. What is the final velocity? 0, right?
0.
So in both the cases, the decrease in mechanical energy is half mv square. So the first statement is false. Second statement, the coefficient of friction between the block and this will
So
decrease.
both are false.
He's asking coefficient of friction. Okay, this is also false. Actually, it should not be coefficient of friction. I think it should be the friction force. Friction force in the second case is smaller because friction force is mu into normal reaction, right? In the second case, the normal reaction is mg cos theta, okay, which is less than mg. In the first case, the normal reaction is mg because horizontal surface. So the friction force in the second case is less than. I think they made a mistake in the question. It should not be coefficient of friction. That's obviously not going to change. Should the friction force, so the second statement is true, and the two statements are not related.
Yeah.
Statement 1 is false. Statement 2 is true. Huh. Let's see the answer. 10 is C. Statement 1 is true. Statement 2 is false. Statement 2, okay, if we take it as coefficient of friction, it is false. Okay. Coefficient of friction is not going to change. Okay. Let it be coefficient of friction only. The decrease in mechanical energy in the second situation is smaller than the first situation. Finally, it will come to rest, right? Finally, in both the cases, it will come to rest, right? So final velocity in both the cases is 0. Oh yeah, oh yeah, oh yeah. Decrease in mechanical energy. So this is equal to.
So it will be same in both cases.
No. It's work done against friction. Okay. So in the second case, the work done against friction. Statement 2 is false. If you take just this as a coefficient of friction is not going to change. It depends on the surface property. So statement 2 is false. And statement 1, decrease in mechanical energy. See, the difference between the first case and second case is the amount of distance traveled. See, in both the cases, the final this thing is 0. So it is a friction force into the distance. In the first case, the friction force is mu mg. In the second case, the friction force is mu mg cos theta. You know why it is theta, right? Cos theta.
Yeah.
This is mg. With the horizontal is theta. So this is with the vertical it is horizontal in the plane. This is also theta. This is also theta. So mg cos theta is the normal reaction. The friction force in the second case is more. Okay. See, there is one more important thing. In the second case, when it's going up the inclined plane, there is increase in potential energy. So MGH is there in the second case. So if you do it carefully, okay. So this is for the first case. This equation is for the first case. There is no change in potential energy. In the second case, the equation will be initial kinetic energy half m v square, that is work done against friction, that is Vmg cos theta into distance v1 plus gain in potential energy. So that is h. Okay.
Yeah.
So decreasing. Yeah.
Yes.
Yeah. This equation is understood, no? Second case.
Yeah, sir, but the method will be false only.
So what is mean by decreasing potential energy? It is kinetic energy plus potential energy. So the work. See, decrease in mechanical energy is EI minus EF, right?
Yeah.
Where E is U plus K. U is gravitational potential energy, K is kinetic energy. Okay.
Okay.
So this is work done against friction.
Right.
So work done against friction is more in which case? That's what I have to find out. Okay. In the first case, work done against friction is half mv square. In the second case, it is half mv square minus mgh. Work done against friction in the second case is less by this much amount. Yeah, so it is smaller. So it is
So
true.
is
Getting it? See, decrease in mechanical energy is this one, EI minus EF, right?
yeah.
That is equal to work done against friction,
Yeah.
and this E is K plus U, K plus UI, both kinetic energy and potential energy. Okay, so basically, whichever is the work done is against friction is less, then that will have less. In the first case, the work done against friction is mu mg, or whatever. It's half mv square. In the second case, it's half mv square minus mgh. So work done against friction in the second case is small. So there is a decreasing mechanical energy. So this quantity is smaller in the second case, and this quantity is this one.
Yeah.
So C is the correct option.
Right.
The statement 2 is very trivial. Coefficient of its surface dependent property. It does not depend on how the inclination is changing. C.
It cannot be any other statement.
Yeah.
So by elimination also we can do.
Okay, try this one. 14. This is also very simple. Increasing kinetic energy is work done, right?
Yeah.
And work done is power into time.
Yeah.
So
It will be
everything is
1.
power is 0.5. The time is 5 seconds. Mass is 0.2 V square. So V is 5.
Okay, sir.
Answer is
Sir,
5.
how?
See, there is
V
only
square will be 2.5.
no 0.2 by 2 is 0.1, right?
Yeah. Okay, sir. Yeah, got it.
V is 5. So there is some work done, that is power into time. That power is 0.5. There is only one form of energy, which is kinetic energy. So the increase in kinetic energy should be the work done, right? Okay, this one. So this is equal to the force. Okay, so work done is in a small interval is F dot ds, right? By definition, and ds is dx I cap plus dy j cap. And the expression for F is there. So it is x dx divided by everything raised to the power 3 by 2 plus y dy divided by raised to the power 3 by 2. And this bracket thing is r square. And r is not going to change from point to point. It's a constant. So r cube. So work done equal to 1 by r cube into x square by 2 plus y square by 2 from these 2 points from 1 to 2. This is 0.1. This is 0.2. Again, x square plus y square is r square. So it is 1 by, or the full r square. It's 1 by r into half. So this is equal to 1 by 2a. Of course, there is a constant k here. So it is k by 2a. What the mistake I'm making?
Sir, the force is conservative.
No. The force is 0.
So answer is D.
Yeah.
Okay.
So the important thing is DS is like this. So it is